Alright, we are on the quiz review, and so the first concept that's going to be covered on your quiz tomorrow is going to be composite functions, and if you don't remember what that is, that's kind of like finding that f of g of x and g of f of x. And so we'll go and give an example problem here. This is example number 1. If I have a function f of x and I have a function g of x, if I'm trying to find f of g of x, I need to close that parentheses, what I need to do is I need to identify the innermost function. Now that's g of x is going to be on the inside, so what I'm going to do is I'm going to take g of x and I'm going to pump it into here. So f of g of x is going to equal parentheses 3x plus 2 quantity squared minus 7. Now I actually need to simplify this, so that is going to be 9x squared plus 6, 12, 12x plus 4 minus 7, and so the final answer is going to be 9x squared plus 12x minus 3. You don't have to refactor this, just go and leave it as is. If I was going to find g of f of x, they're going to reverse positions. F of x is now the inner function, which means now x squared minus 7 is going to go into 3x plus 2. So it's going to be 3 parentheses x squared minus 7 plus 2. And now I just go ahead and distribute in. I get 3x squared minus 21 plus 2, which simplifies further into 3x squared minus 19. And that's my answer. The next type of composite function they can give to you would be to give you f of g of a number. In this case, the number is going to be -4, or g of f of -4. So what we do is if we have a problem like number 2 here, what we're going to do is we're going to plug the innermost function in first. So I'm going to try to evaluate g of -4. So g of -4 is really -4 minus 8 over 3. Well, -4 minus 8 is -12 over 3, so g of 4 is equal to -4. And what I do now is I take -4 and I pump it into f of x. So what I really do is I'm evaluating f of -4, right, because -4 here pumps into there. So I get 2 times -4 squared minus 5 times -4 plus 8. Well, that's 16 and that's 32. This is positive 20 and this is 8. So 32 plus 20 is 52 plus 8 is 60. And that's f of -4, but let's go and finalize it by writing out the problem they wanted us to find. F of g of -4 is equal to 60. Likewise, if they wanted us to find g of f of -4, let's go ahead and do that. So this time f of -4 is the innermost function. So f of -4, I'll just go ahead and do that one more time. F of -4 is 2 times -4 squared minus 5 times -4 plus 8. As we saw from the last problem, this is 16, so that's 32 plus 20 plus 8. This is 60. So f of -4 is 60. So now we're going to pump that. We're going to pump 60 into g of x. So g of 60 is 60 minus 8 over 3. 60 minus 8 is 52 over 3, and I don't believe that can be simplified, so that is what you get. And so if I had to write this as a complete answer, it would be g of f of -4 is equal to 52 over 3. Now what they do sometimes is they might give you a chart, and they might ask you to find the same thing. So let me go and erase this thing real quick here. So in a chart, to find f of g of -4, well, I need to first evaluate g of -4. Let me go and switch colors here. G of -4. Well, g of -4, this is my g function down below. G of -4, well, that gives me 0 equals 0. And now I'm going to take that and plug 0 into the f function, and where I had 0, I had 5. So therefore, I can say that f of g of -4 is equal to 5. Let's do a different color here for the next one. G of f of -4, well, f of -4, when I pump -4 into the f function, I get a 2. And then I take 2 and plug it into the g function. Well, g of, actually, let me back up here, f of negative 4 is equal to 2. And then g of 2 is equal to 3. So therefore I can say g of f of negative 4 is equal to 3. And those are my answers for that problem. Alright, the next topic is going to be inverse functions. That's going to be showing up on your quiz tomorrow. The first thing they're going to ask you to do is find the inverse of the function. In order to find the inverse of a function, what you do is you switch x and y, and then you solve for y. So I'm going to solve for y by subtracting 3 from both sides. So what I get is x minus 3 equals 2y squared. I'm going to divide by 2. So what I get is y squared equals x minus 3 over 2. And then I'm going to take the square root of both sides. So I get y equals plus or minus the square root of x minus 3 over 2. Right, so again, you just switch x and y, and then you solve for y. That's all I did. I'll go into another example. Y equals 1/5 x plus 1. So again, I'm going to go ahead and switch x and y right off the bat. And now I just solve for y. Whoops, that should be a y right there. So now I'm going to subtract 1 from both sides, and I get x minus 1 equals 1 over 5y. Now I'm going to multiply everything by 5, and remember, I'm multiplying the whole thing. So this is 5x minus 5 is equal to y, and that is my inverse function. Next concept they're going to ask you to do is determine whether or not the functions are inverses. Now remember, this rule about inverse functions are only inverses. So functions are inverses if and only if f of g of x equals x and g of f of x equals x. So what we're going to do is we're going to compile these two functions to see what happens. If I get x for both, then they're going to be inverses of each other, and the answer is a simple yes or no. So let's go ahead and find out what f of g of x is. F of g of x, well, g of x is going to get plugged into f of x, so that is 2 parentheses 3x minus 5 over 3 minus 3 over 5. That's kind of ugly, but all I did was I just took 3x minus 5 over 3 and pumped it into the x right there. And I have a funny feeling about this problem. That's going to give to me 6x minus 10 over 3 minus 3. So let's go ahead and get our common denominator here. This is 9 over 3, so that is 6x minus 19 over 3. No, these are not inverses of each other. Let's take a look at the next one. I'm going to pump f of g of x in and see what happens. F of g of x is going to be 5 parentheses x plus 6 over 5 minus 6. Well, these are going to cancel each other out. I get x plus 6 minus 6. Those cancel each other out. So f of g of x equals x. Looks promising. Let's try the next one. If I try g of f of x, let's see what happens. If I go g of f of x, well, g of f of x is going to be 5x minus 6 plus 6 over 5. Well, the 6's are going to cancel each other out, leaving me with 5x over 5. The 5's cancel each other out, leaving me with x. So we can say, yes, they are, in this case, inverses of each other. The next topic on your quiz is going to be inverse and direct variation. A couple things you guys got to remember. The direct variation model, so direct variation is going to be y sub 1 over x sub 1 equals y sub 2 over x sub 2. Now, since we're dealing with direct variation in problem 1, this is the model we're going to use. And so what we're going to do is we're going to identify all of our parts, y sub 1, x sub 1, y sub 2, x sub 2, and we're going to find out what we're going to solve for. It says if y varies directly as x and y equals 16, so that means that y sub 1 is equal to 16, when x sub 1 is equal to 4, we need to find y sub 2 when x equals 12. Well, when x sub 2 equals 12, y sub 2, who knows what that equals. So we're going to set that up as a proportion using this model here. So 16 over 4 is going to equal y sub 2 over 12. I'm going to go and reduce 16 over 4 to get 4 over 1 equals y sub 2 over 12. I get, when I cross multiply, y sub 2 equals 48, and that is my answer. Next problem, if x varies inversely as y and x equals 12 when y equals negative 3, find x when y equals negative 18. Well, the inverse variation model is like this. It's x sub 1 over y sub 2 equals x sub 2 over y sub 1. And so, again, we're going to treat it just like the last model. Whoops. Y sub 1, x sub 1, y sub 2, x sub 2, and we're going to find out what each of these are, and then we're going to plug them in. When x equals 12, well, x sub 1 is going to be 12 when y equals negative 3, so that's y sub 1. We're going to find x, oh, this time it's a little different, when y equals negative 18. So let's go ahead and plug those in. X sub 1 is 12 over y sub 2, that's negative 18. And that's going to equal x sub 2, well, that's what I'm trying to find, over y sub 1, which is negative 3. Again, just like the last problem, I can go and reduce those down. They both divide into 6. That's 2 over negative 3 equals x sub 2 over negative 3. Well, I can cross multiply. That is negative 6 equals negative 3 times x sub 2. If I divide both sides by negative 3, what I get is x sub 2 equals 2. All right? That is direct and inverse variation for you. Okay, so I have passed over the sections on adding and subtracting and multiplying and dividing rational expressions. Look to Learning Point for the videos that I made back when I was teaching Extended 3-4 last year. I've linked them to the Learning Point page, so go ahead and just check those out. Let's see here. Solving rational equations is going to be the last thing that's going to be on your quiz tomorrow. So when we solve a rational equation, remember, as long as the denominators equal each other, the numerators should equal each other as well. So all I have to do is find a common denominator to get all my denominators to equal each other. Well, in this case, my common denominator for problem number 1 here is x minus 3 times x plus 5. So what I have to do is I have to figure out what's missing from each term, and I never give myself enough space. Hang on for 1 second. I got a float builder in here. Hold on. Okay, cool. So what I'm going to do is I'm going to multiply the right by x plus 5, top and bottom. The center, well, I never seem to leave myself enough space, but hopefully you guys know that I'm going to multiply the center by x minus 3. And then the left term, rather, I'm going to multiply by x plus 5. So what I get is x plus 5 times x minus 3 over, or rather, under x plus 5 plus x plus 5 times x minus 3, all of that underneath x minus 3, right? This is just distributing all this stuff. And that's going to equal x plus 5 times x minus 3. And this thing I'm actually going to have to FOIL. So this is x squared. This is 5x and 1x, so that's 6x plus 5. Okay, well, since all my denominators equal each other, I can cancel them all out because my numerators are going to equal each other. So this is x plus 5 plus x plus 3, or rather x minus 3, whoops, equals all this stuff here. Okay, so let's go and solve for x. Whenever I have an x squared term, I got to set it all equal to 0, so I'm going to go and combine my like terms first. 2x plus 2 equals all of this stuff again. That's going to cancel with that. I get a 4x. This is going to cancel with this. I get a plus 3 and x squared. All of that equals 0. So 0 is going to equal x plus 3 times x plus 1. So in this case, x is going to equal negative 3 and negative 1. Well, here's the problem. is that if I allow x to equal negative 3, and this is kind of what we learned yesterday, if I allow x to equal negative 3, I have a problem in my domain. So x cannot equal negative 3, it only equals negative 1. Let's try another problem here. Whenever we have a problem that looks like this, we should probably factor the denominator first. So I'm going to factor the bottom into x plus 4 times x minus 2. And that's all under 3x. Bring down everything else. I know to leave myself enough space this time. Okay, so what am I missing here? My common denominator is going to be this denominator down here, x plus 4 times x minus 2. So let's go ahead and multiply by what's missing. What's missing from the right term is an x minus 2. And what's missing from the center term is an x plus 4. So what I get is 3x over x plus 4 times x minus 2 equals, I'm going to multiply the x plus 4 in, so I get x plus 4 over, I'll go and just call this common denominator, plus, this is going to be x squared minus 2x over common denominator. Since all my denominators are the same, they all go away. So it's the same thing as the last problem. I get 3x equals x plus 4 plus x squared minus 2x. Let's go and combine what we can. This is going to be x squared minus x plus 4 equals 3x. If I move 3x over, what I get is, let me go and clean some of this stuff up. I got to get some of this stuff out of here. What I get is x squared minus 4x plus 4 equals 0. And I'm going to go and factor it. So it's x minus 2 times x minus 2 equals 0, so x equals 2. Now let's see if that could actually happen. The original problem was 3x, and I can already see it from here in the book, x squared, blah, 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 equals 1 over x minus 2. Well, if I plug a 2 into here, I get a problem. So since that's my only solution and it doesn't work, the answer is actually no solution. Alright, so go ahead and look to the other videos for how to do the inequalities and the adding and subtracting and the multiplying and dividing. We'll see you tomorrow.